but we're gonna go back to this one. So I'm gonna think about that and get back to you, because I don't wanna waste your time. All right, so let's go to example 7, something a little simpler. What if you have things like this, where it's like 3 minus 4i, so this is one that was already broken down, and negative 2 plus 6i. You guys know how you can combine those?
It's just like with the like terms and
Right.
stuff.
It's just like with variables and like terms, so you combine the i's together and the other numbers together, so this turns out into 1 plus 2i. Feel good about that?
Yeah.
We don't need more examples of that, right? Example 8, last one. Let's do this. 2 minus 3i times 3 plus 4i. All right, now before you start going on this problem, this is multiply, not adding, right? So you're not going to combine like terms. How do you multiply two things in parentheses like that? Foil or the box. And remember this, look at me. I squared equals negative 1. So when you get an I squared after doing the box or the foil, change that I squared to a negative 1. Simplify with your partner, okay? I'll put up the right answer up here. We'll see who wants to come up.
Me now, they aren't allowed to go up anymore.
Correct.
Like ever.
Just today? Yeah, ever. For the rest of your whole lives. You're going to come to me when you're 48 and be like, can I quickly go? And I'll be like, no. Will I be alive when you're 48? I assume so. But I won't probably won't be teaching.
Okay, well, I
You
squared
hope
is
not.
Yeah?
So 2i, I squared makes negative 1.
I squared makes negative 1.
Yes, so like 3 and 4 would be negative 12, or 3 and negative 4 is negative 12. So it'd be
Times a negative 1, which is,
12.
yeah.
But no I.
Right. No I on that one. Your final answer is going to be 18 minus I, so talk to your partner and work through it together. Talk to each other.
Not done yet, but like. Oh.
Oh, right.
Oh. Oh, I'm understanding my mistake.
Right. Yeah, what you just said, like went, like right over my head. Yeah, because it's 12
No, because the 2 is just a regular 2. No, this is right. And then you just multiply it with
Oh, because I added the 6 altogether.
Okay.
Oh, because I thought that was a 2.
I know, it's 6.
I understand the mistake we made on example 6, so remind me to go back there.
Yeah, I just thought that was a 2.
And combine like
Okay, so now it's
by
8.
adding them. Like negative 9
Hmm? Because it's I squared. Yeah, you get it, smart chance. Was it a dumb mistake? Wait.
No, it was something that, I mean, one of them was a dumb mistake, but the second one was something you guys don't know yet. Something rationalizing the denominator.
18. Not a square root.
Yep.
So I'm gonna just be 18. I guess that makes sense.
Yeah, it'll be pretty easy once I explain it. All right. So, raise your hand if you got the correct answer. Not if you want to come up here, but if you got the correct answer. Awesome. And which teams want to come up here and show me? All right. 1, 2, 3, 4, 5, 6. 1.
What is wrong with
He's having a lot of size today, okay?
Yeah.
Have you ever had a day where you had a lot of size, Jackson?
Jackson, you saw everything. No way. Okay, so.
Oh, can you come over here?
Me?
Yeah.
Okay, Alma?
Did you say my name?
My name.
Yes, I did.
Me? My name?
Okay, so we're plugging in the numbers on the outside of the box, and then we're multiplying them into their spots.
You like this creepy water filling noise on the video? Okay, I'm done.
Yes. Okay, and then now you can write the numbers that were in the box, and then you got 12 because I squared is -1, so -12 times -1 is 12. And then you just combine the like terms and finish with 18 minus that.
Perfect, great job. Wonderful job. You want some of my water signs?
Yes.
Oh, I'm sorry. Is 2. Okay, let's go back to example 3 and look at that really quick, and then we'll be done. There you go. All right. So if I go back to example 6, here's what we did wrong. Do you remember how we took 48 divided by 24?
Yeah.
We got 2. That's correct, right? Look up here. Do you see how we took 7 times 7, but we kept it under the square root? So this actually should have been I times the square root of 2, not 2I. Because 48 divided by 24 is 2, but it's still under a square root, okay? Now down here, okay, yep, it's still under a square root. Now, all right, so definitely when you're doing your homework, do it this way, okay? Ignore this way, but I do want to go through it really quick why it went wrong, yeah?
So like if it is a, wait, you said no decimals in the square root.
Right.
Okay.
Okay, so I'm going to write it like this. I should have just gone with the way I knew, but I'm glad that we did it this way. Okay, so do you see how the square roots of 3 cancel out? And I wrote square root of 6 as the square root of 3 times the square root of 2. You okay with that? Okay, again, you don't have to do it this way. I'm just trying to explain to you why this works. What do the 4 and 2 cancel out to be? On the top or the bottom? All right, so now we're down to this, which is 2I over the square root of 2, correct? This is a process called rationalizing the denominator, which is actually something that you are going to have to learn, but not for a few days. Did you ever talk to Mr. Thorson about rationalizing the denominator? How you can't have a square root in the bottom of a fraction?
Okay, I think you did.
Yeah.
So there's a couple stupid math rules, and the reason why they exist is to make sure that basically that mathematicians all over the world are rounding to the, or basically making their answers simplified in the same way. And I don't really like this rule, but I will tell you that it's constantly in math team, it's constantly everywhere. So what you do to get rid of a square root on the bottom is I multiplied by the square root of 2 over the square root of 2, which is essentially me multiplying by what? 1, which I'm allowed to do. So I end up with 2I times the square root of 2 on the top. And on the bottom, what's the square root of 2 times the square root of 2? 2, right? Because the square root and the square root kind of cancel each other out. Because it's like the square root of 4, which is 2. And then do you see how those cancel out and you end up with I times the square root of 2? Okay, so it does work, but again, don't do it this way because it takes way too long and it's way too complex, but it was driving me nuts why they weren't equal. Yes.
Who made these rules?
Mathematicians, because they were sick of sometimes having square roots in the bottom and sometimes having square roots on the top, and then problems like this where we couldn't figure out why they weren't equal when actually they turn out to be. And so they just kind of made it uniform, like we're all going to do it this way. and which is the only thing that is accepted in Math League, and when you go to college, it will be required and accepted there. So there are a few things, like, for example, like them saying, and my answer is 4/8. And mathematicians going, yeah, but that reduces to 1/2. You always have to reduce your fractions. So they're always trying to, because then you could have mathematicians who are like, the answer is 1/2. No, it's 4/8. No, it's 6/12. No, it's 8/16. You see how like we could all have different answers, but if we make the rule, look, you reduce it, then everybody says 1/2, and we all know that we're at the same place.
Learn all these rules.
By going to college and for a long time, or being, I mean, you guys know most of the rules at this point when it comes to the basic math. This is like the last one you don't know. Like, for example, tell me what you can't divide by. 0. You can't divide by 0. Everybody know that rule?
Zero.
Right? Okay, you and I can talk about that, but I'm gonna,
I knew the rule and I didn't.
you definitely know that rule. Because I taught you that rule myself. Yep. But, you know,